Okay, folks, this is a grand experiment. I am attempting to use the Smartboard software to record myself invisibly. Pretty cool. You don't see me because, well, I'm invisible. Um, let's see if this works. First of all, this is the geometry page 277 review in preparation for the test. The test will be emailed to parents tomorrow morning. It'll be due back to me, emailed back to me by 3 o'clock tomorrow afternoon. If it is not emailed back to me on time, it will be considered late and there will be an automatic 10-point deduction. Okay, there may be further deductions if it comes in even later. I don't know. I'll figure that out later. All right. I've had some of you who have not been following my convention for describing the item in the subject line. Please, in the subject line, just put the word geometry and the page number. That's it. There's no need to put your name in there. Don't just say page 277. You don't even need to describe the entire assignment. Just write geometry, page 277, or whatever the case may be. That's all there's that. Please, everybody follow that. I think most of the problem has been with the algebra classes. You guys, I think, have done pretty well at this, but not everybody. Thank you. All right, now, starting with number 1 on page 277, 15 to 25. What you see here, it's weird. I'm pointing at the screen as if you could see me. This takes some getting used to. But 15 over 25 means the same thing as 15 to 25. It is a ratio. Whether you write it that way, or whether you write it this way, it's still just a ratio. You reduce that ratio as you would any other ratio. Divide by 5, divide by 5. We get 3/5. There's no need to go through that step. You can do it straight from here and say, oh, divide by 5, divide by 5, you get 3/5. You're done. For number 2, it's a three-way proportion. This is actually 3 ratios built into one. It means 6 to 12. It means 12 to 9. And it even means 6 to 9. The first with the last. All right, so to reduce this one, the trick is, as we mentioned in class on one of those last days before you guys decided to stop coming into school, you divide all 3 by something, or you divide by nothing. I can divide 6, 12, and 9. I can divide them all by 3. So I do divide them all by 3. Divide by 3, divide by 3, divide by 3. I'm done. Notice that it may be tempting to reduce the 2 and the 4, but you can't reduce the 2 and the 4 because you can't do the same thing with the 3. So forget it. It's all or nothing. As soon as you get down to 2 to 4 to 3, you're done. There will be a problem very much like that on the test. Number 3, over here on the left side, number 3 is an ordinary algebra expression to be reduced. The 16 over 24 part of it, the 16 over 24, you reduce like any ordinary fraction, and this becomes, so divide by 4, no, better than that, divide by 8, and divide by 8. Dividing by 8 there, dividing by 8 there. Then what happens with the x's? Well, we've got x and we've got x squared. You may hopefully remember from algebra that this x will cancel out one of those x's, which gives you, it's kind of tricky to not be able to point at the screen, which gives you the top x disappears and the bottom x squared turns into just plain x. There's the IRS trying to get me again. Put them off. The x in the numerator is gone. And for the y, there's nothing to cancel it with, so the y just sits there like that, and you're done. Your reduced fraction is 2y over 3x. Hopefully that's really clear. Number 4, we saw some of these in class last time we met. We know that the sides, wait a moment, what is the point of this problem? I need to look in the book because I don't remember. Number 4, oh, I wrote something weird here. It's the ratio of the angles, sorry. The ratio of the angles of a triangle are 4 to 4 to 7. The angles are not actually 4, 4, and 7. The angles are actually 4 times something, 4 times something, and 7 times that same something. We know that those 3 angles have to do what? They have to add up to 180. Oh, well that's easy. So now we just add this stuff up. We get what? 15x. 15x equals 180. Divide by 15, and we find that we get a result of 12. Dividing by 15, dividing by 15. So we find x is 12. Is that our final answer? No, that's not our final answer. That just tells us the mystery number that everything is to be multiplied by. We now know the mystery number is 12. So now we multiply that out. 4 times 12, let's go down here a little ways. 4 times 12, 48. 4 times 12, 48. And 7 times 12, which is what 7 12s would be, 84. If we were to add these up to test it out, we would find out that indeed they do add up to 180. Okay, hopefully that's pretty clear. We move on to number 5. For number 5, let's see. Oh, we simply want to know if those two are equal. Oh, we're given something. There's got to be something given that I don't. Oh, there's what's given in yellow. Let me get rid of this. Okay, I haven't seen this file since last year, so I'm forgetting how I had this formatted. All right, they gave you this proportion. Now the question is, did they or did they not do something legal? What in the world are they doing here? They're multiplying 7 times x. They're multiplying 7 times x. That's not how you cross multiply. Don't be silly. So this is not equal. Number 5 is not correct. So I'm just going to change that to a not equal to sign, or you would probably simply write, no, that's not correct. Number 6. This time what did they do? Oh, look at this. It seems that they simply put the denominator into the numerator and put the numerator into the denominator. In other words, they did what I call reading it upside down. Well, if they read the left side upside down, they should read the right side upside down. Did they? Yes, they flipped both numerator and denominator, so that is done correctly. That is a most definite yes. They are indeed equal. Number 7 looks like another attempt to cross multiply. Did they do it right this time? Well, they took the 8 times the x, and then, oh, did they do the 7 times the 30 minus x? Well, sure they did. 7 times 30 is 210. And minus 7 times x is 7x. Yes, they did it correctly. They did indeed cross multiply. That one is indeed correct. Number 8. Oh, what a mess I've made. Let me clean this up. I'm wondering, I don't know if you can see my arrow. If I use the arrow to point at things, no, that's not going to work. No, wish I had a way to point at stuff easily without actually drawing. Anyway, what in the world did they do here? 30 over x, where did that come from? Well, looks like the minus x disappeared. Oh, well they must have taken this guy and added x, so these canceled. Yes, they simply added x to this numerator. They added the denominator to the numerator. Hey, remember that's that weird rule that says I can add the denominator to the numerator here. I'm pointing again. You can't see me point. I'm not sure I like this format. We're adding the denominator to the numerator, so we must do the same thing here. We add the denominator to the numerator here as well. That gives us 15 over 7. Ooh, look at that. Exactly what they have here. So all they did was they added the denominator to the numerator, giving us, bang, gone, 30 over x equals 15 over 7. Number 9. All right, we don't even need a diagram. In fact, if I flip the page, I believe they didn't give you one. Nope, don't need a diagram because this tells us everything we need to know. If triangle ABC is similar to triangle NJT, well, we know that the corresponding parts must match up together. So we know that the A must match up with the N. We know that the B must match up with the J. And we know that the C must match up with the T. Therefore, we know, based on this similarity, we know that angle B must be congruent to angle B matches up with J. There is no other correct answer. Number 10. Number 10, again, no diagram, and that's okay. If quadrilateral DEFG is similar to quadrilateral PQRS, again, corresponding parts match up, then FG over RS must be equal to GD. How do we get GD? GD would be this guy over that guy, must be equal to S over P. So GD over SP. We're simply matching up the corresponding parts. Now we go on to number 11. For number 11, we again have no diagram. We don't need one because they told us the similarity right here that triangle ABC is similar to JET. They also told us that we have a scale factor of 5 to 3. Why, thank you for telling us that. Looking in the book, is that given or is that something we figured out? Number 9, yes, they told us the scale factor was 5 to 8. Wait a minute, I'm on the wrong page. There it is, yes, they told us the scale factor is 5 to 3. Okay, that being the case, if BC is 20, then ET must be, here we go. So we know the scale factor is 5 to 3. And we have BC being 20. We don't know ET. We don't know ET. Well, guess what? 4th grade method. 5 times 4 is 20, so 3 times 4 is 12. ET has to be 12. All right. For the perimeters, it's exactly the same rule. For the perimeters, if the perimeter of JET is 30, we're looking for the perimeter of ABC. By the way, what's perimeter? Perimeter is the distance around. If I start here, how far do I have to walk if I'm going to walk all the way around the triangle? That's called perimeter. It's this side plus this side plus this side, x plus y plus z, whatever they may be. That's perimeter. We're told the perimeter of JET is 30. Now watch out. Ooh, notice my little note down here. Watch out. They're being mean to you. They reversed this. They gave you the perimeter of JET. That matches up with the 3 in your scale factor. ABC is the 5. So what do we do with that? We write, I don't have enough space here, let's put it right over here. So our scale factor is 5 to 3. That's equal to the perimeter of JET, we'll call it x, over 30. Notice it's ABC, back up here again, ABC to JET. So I've got to put JET in the bottom. So JET is in the bottom. I'm looking for ABC. Again, third, fourth grade method works great. 3 times 10 times 10, so 5 times 10 is going to be 50. X is 50. The perimeter of ABC is 50. And just to make sure I don't make any silly mistakes, I'm looking at the answer in the book, and that is, of course, correct. Number 12. For number 12, let's get rid of this now. If you need to see that again, you can always back up. Just trying to get some more space here. All right. For number 12, we're told the two polygons are similar. There we go. And we're told that this is a right angle. Therefore, this must also be a right angle. We're told these angles are congruent, so that tells us how this works, that you have to flip one of the polygons to see how it matches up with the other one. So this point here matches up with this point here. Likewise, this vertex matches up with this vertex. The right angle matches up with itself. All right, so what's all that mean then? We look for two corresponding sides where we know the lengths of the sides. How about this? The 8 matches up with the 12. Therefore, the scale factor is 8 to 12. Be nice to yourself. Reduce that. Divide by 4. Divide by 4. Our scale factor is therefore 2 to 3. So 2 to 3 equals what? 2 to 3 equals 6 to x. And by the way, 2 to 3 also equals 9 to y. 9 to y. And again, the fourth grade method works. Here 2 times what gives 6? 2 times 3. So 3 times what? 3 times 3 gives 9. X is 9. Okay, then over here. Oh, this may be the first time they did it to us. We can't use the third grade method here, at least not easily. So we're going to have to cross multiply. Lo and behold, they finally did it to us. Because what do you multiply 2 by to get 9? Well, it's true that you would multiply by 4.5, but who wants to mess with all that? So we are going to cross multiply, which means 2 times y, 2 times y, 2 times y equals 3 times 9 equals 3 times 9. 2 times y equals 3 times 9. By the way, that only works in a proportion. Only when you have an equal sign here can you do a dastardly thing like cross multiplying. 2 times y equals 3 times 9. What good is that to us? Well, now we have 2y equals 27, so y equals 27 halves. Otherwise known, by the way, as 13 and 1/2. I wonder how the book expresses that. They wrote it as 13.5. I'm fine with you leaving it as 27 over 2, or 13.5, or obviously, everybody knows 13.5 is the same thing as 13.5. Any of those three answers are perfect. Okay, that was number 12. Where's number 13? Must be over here, yes. Number 13. All right, this time, interesting. We have n degrees here and n degrees here. That's their tricky way of telling us that these two angles are congruent. And we have j degrees here and j degrees here. That again is their tricky way of telling us that these two angles are also congruent. Well, AA right here tells us that these two triangles are definitely similar. They are similar. Now we have to write the similarity. To write the similarity, we have to make sure we get the corresponding parts matched up. Well, pretty clearly, well, let's start here. If they started with R, we have to start with R matches up, not with H, R matches up with, see this, R matches up with U. So you have to start with U. T matches up with itself. These angles are congruent. So T, not with itself, T matches up with V. And then S, the only thing left, matches up with H, the only thing left. The only correct answer is UVH. Any other order is wrong. And again, the reason that we know they're similar is because of AA. Here I am, I'm pointing at the board again with my finger, and of course you can't see me do that. I'm not sure I like this format. Now, once we know that, cool thing is, we don't even need the diagram anymore, because we can simply look right here at the statement of similarity. We know the corresponding parts match up, so that means that RT must match up with UV. So RT over UV must equal TS over VH, TS over VH, and the last one, RS, that would be first guy and last guy, must be equal to UH, first guy over last guy, so we have UH. Corresponding parts simply matching up. And that's all there was to number 14? Yep, that's all there was to number 14. Number 15. If we wanted to prove that RS times UV is actually equal to RT times UH, it looks like they did what? It looks like they cross-multiplied something. So we would have to start with, watch this. If we start with that proportion, RT over UV equals RS over UH, then we could simply cross-multiply, and that would give us RS times UV equals RT times UH, exactly what we're looking for. So what proportion would we start with? We would start with this proportion right there. So from there, what are they doing? What are they asking us for? Number 15, looking at the book. So that means that, what are they doing? You would first, oh yes, they want us to write this out, write this thing out, that's all. So you would start with RS over UH equals RT over UV. All right, kind of awkward wording for the problem, I think. I would not make the test that tricky. On the test, you use these things, but you don't have to go through all the stuff we're seeing here in numbers 14 and 15. Number 16. Okay, yes, very common test type questions. Are the triangles similar? If the only thing we know, number 16, yes, if the only thing we know is that angle A is congruent to angle D, that angle A is congruent to angle D, that's all we know. Does that prove that the triangles are similar? Well, what else do we know? The old friend from way back in like chapter 3 or something, our old friend, no, it was actually chapter 2, theorem 2-3, said that vertical angles are always congruent. So guess what we've got? We have two angles here congruent to two angles here, and that's AA. So that tells us, yes, they are similar by AA. Now, the instructions also asked you to state the similarity. What in the world does that mean? Stating the similarity means to write it out as triangle. Let's call the first one ABN. Triangle ABB, not D. ABN is similar to triangle, and A matches up with what? This guy goes with this guy. So A matches up with D. Then B is next. B matches up with C. B matches up with C. And the only thing left, N matches up with, N matches up with itself. N matches up with N. So we have our corresponding parts matching up. We have correctly stated the similarity. We have also given the postulate or theorem. It's the AA postulate. Number 18. I need to clean up the diagram, obviously. Did I lock this? I did lock it. Good. I can erase all of that. All right. So now we go back to the beginning. For number 18, we're told that CN is 16. CN has a length of 16 from here to here. The distance is 16 units. That's what this means. We're told that ND is 14. ND here is 14. The distance from here to here, if I put a ruler on there and measured it, will be 14 units. We're told that BN is 7. BN is 7. We're told that AN is 8. AN is 8. So now the question is, are these guys similar or not? Well, what have we got here? We clearly have the theorem that vertical angles are always congruent. So now the question is, do we have side, angle, side, or not? Do we have SAS similarity theorem? Well, to have SAS similarity theorem, we have to have proportional sides and the congruent angle in between. Well, we do have the congruent angle in between. Nice. But are the sides proportional? So to test that out, we're going to match up in the top triangle. We're going to match up the smaller side, 7, not 8. We're going to match up the smaller side, 7, with the smaller side here, which is 14. So we'll write 7 over 14. We're asking if that's equal to, then we match up the big side here, 8, with the big side here, which is 16. Well, is 7 over 14 the same thing as 8 over 16? You could go to the trouble of cross-multiplying to find out or whatever, but hey, look at this. Doesn't 7/14 reduce to 1/2? And doesn't 8/16 also reduce to 1/2? Meaning that those two fractions are proportional, the ratios are proportional, the sides are proportional, the triangles are indeed similar. Yes, for what reason? You can simply write SAS, I suppose, although you should write SAS similarity theorem, because this is definitely not the SAS congruence theorem. Let's go on to number 19. And I don't have, let's do this. Can I move the whole diagram down, or is it locked in place? It's locked in place. How about if I unlock it? Okay, now can I move the whole diagram down? No. Oh, come on. This is more trouble than it's worth. Let's just flip back and forth. We can do it like this. We can still see everything. Let me erase this, got all this out of the way, got all this out of the way. Okay. Moving on. So, this time, we're told that AN is 7. AN is 7. We're told AB is 13. AB is 13. We're told that DN is 14. DN is 14. And DC is 26. DC is 26. Well, there's a little problem here. We, of course, do have our old friend, the vertical angles here, but wait just a moment. The vertical angles, the congruent angles, are not between the sides. They gave us the wrong angle. They should have given us this one and this one. They gave us the wrong angles. So guess what? This is not SAS. This is nothing. We cannot know that the triangles of number 19 are similar. We do not know. And I just realized, I think we skipped one. Let's see, this is number 19. Okay, good. And we did indeed, we skipped number 17, didn't we? Yeah, we were really wondering about that. Okay, sorry about that. 17, let's clear all this. Oops, oh, I unlocked it. Yes, there are disadvantages to unlocking these things. Okay, I'll just, what a mess. Let me just erase that, and that, and that, and that. Okay, good enough. And I'll fix this. There, that's better. All right. For number 17, we were told that angle B was congruent to angle D. Okay, if B is congruent to D, do we have similar triangles? Yes, we do. Because we have two sides similar to two angles. Good grief. I'm writing without thinking and talking without thinking. We have two angles congruent to two angles. That's called AA. So yes, they're similar by AA. Now, to state the similarity, let's call the first triangle ABN again. Now we have to figure out who matches up with who. Well, this time, B matches up with D, unlike number 16. N, of course, matches up with itself. Therefore, A must match up with C. So for this guy, if I call the first triangle ABN, what matches up with A? C. Triangle C. Then what matches up with B? If B is in the middle there, I've got to put D in the middle here. And the only thing left would be C. Let's make sure, I'm sorry, not C. The only thing left is N. They put N at the end. N matches up with itself, so N corresponds to N, and we have stated the similarity. And we already did number 19. Now we move on to number 20. Okay, so what are the instructions for 20? Are they the same instructions? Yep, we are deciding if the triangles are similar, and if they are, what's the, we are to state the similarity and give the reason. Well, notice, did they give us any information about angles? No, nothing about angles. They told us the lengths of all three sides for both triangles. They gave us no angles. If they gave us no angles, it certainly can't be AA. It certainly can't be SAS because they gave us no angles. So the only remaining possibility, it's going to be SSS or nothing. SSS or nothing. So we need to check it out and see if it works. Some of these work, some of these don't. So how are we going to check that out? We write three ratios. For the little triangle, we find the smallest side. There it is, 8. And in the big guy, we find the smallest side. There it is, 11.2. We write a ratio, 8 over 11.2. We ask ourselves, is that equal to? Then let's go with the middle-sized guy over here, the 11. And the middle-sized guy on the other one is going to be the 15.4. So we're going to put here 11 over 15.4. And we're going to ask ourselves if that is equal to, then we go for the big guy over the big guy. The big guy here being the 15, and the big guy here being the 21. So I write 15 over 21. Now there's one place where we can be nice to ourselves very easily. We can reduce 15 over 21. Nice. Divide by 3 and divide by 3. That gives us 5 over 7. That gives us somewhat smaller numbers to work with, makes life a little bit easier. At this point, you probably go ahead and pull out the calculator. How do we test to see if this is a true proportion? We multiply 8 times 15.4, and we multiply 11 times 11.2. And let me grab my calculator over here. By the way, I cannot find my beloved Casio FX300 ES calculator. I suspect I loaned it to a student who forgot to return it. if you happen to have my calculator, please bring it to school sometime, drop it off at the office, or if you can't get anyone's attention, I don't know. If I'm in here, which I am every day, knock on my window or something. But I really miss that calculator. 8 times 15.4 is 123.2. And then we have, clear, 11.2 times 11 is 123.2. How about that? 123.2. Is that enough to settle the issue? No, it's not. Because I also have to check the 5/7. So I'll also do the 5 times 15.4 and the 7 times 11. Well, 5 times 15.4 is 77. And of course, 7 times 11 is also 77. They check out. Therefore, yes, these sides are proportional. The cross multiplication is checked out. And we know the triangles are similar. By the way, we could have also done 8 times 7 and 5 times 11.2. That would also have worked. Now that we know they're similar, and the reason being SSS, now we have to state the similarity. Stating the similarity, we write triangle such and so. Let's call the one on the left whatever we want. I'm going to call it P. Let's call it PEX. And that's going to be similar to triangle. Now, very nice of them to put the two triangles in the right orientation. It makes it too easy. But suppose it wasn't that easy. How would I know what matches up with what? Well, let's look at, for instance, I've started with P here. Where is P? P is between the middle-sized guy and the big guy. So what over on the other side is between the middle-sized guy and the big guy? Between the middle-sized guy and the big guy, we have point H. So I must put H here. Then we have put E in the middle. If E is in the middle, then I've got to put something special in the middle on the other side. Well, where is E? E is between the little guy and the big guy. Over here, there's my little guy. There's my big guy. What's between the little guy and the big guy? It is U. So U has to go here. Then the only thing left, this is going to be T, but let's just do it anyway for practice. T has to match up with X. Well, where is X? X is between the little guy and the medium-sized guy. Over here, here's my little guy and my medium-sized guy. What's between them? Point T. So we are, of course, correct, but we already knew that. All right, that's number 20. We move on. What's next? 21. This should be relatively easy. This is checking us out on the stuff that we looked at in the last video. We have OS over ST. That's OS over ST. They're claiming that's going to be equal to OV over VW. OV over VW. Did they do it right? Yes, that's what we were calling A over B equals C over D. This one is correct. How about number 2? Oh, by the way, they did, in the instructions, they did leave open the possibility that it could be more than one that's correct, if I remember properly. Okay, why does my book say that that's not correct? What have I done? Which proportion is incorrect. They're asking which one is incorrect. All right, so it's not number 1. How about number 2? Can I do this? Yes, I can. Good. Number 2 suggests that SV over TW might be proportional to or equal to OS over ST. They blew it that time. Because remember how you think about this. Look back at the old video. You compare the side of the whole side of the small triangle that's SV, to the whole side of the big triangle, that's TW. If you're going to do whole side to whole side, then here you have to do whole side to whole side. It should have been not ST, it should have been OT. So they blew it. This one was incorrect. So number 2 was your answer as to which one was incorrect. Let's see why 3 is correct. Why is 3 correct? 3 says OT, the whole side of the big triangle, over OW, OW being the whole side of the big triangle, is that equal to OS over OV? Well, the trick is, as long as you're consistent in what you do on the left and the right sides, it's hard to go wrong. That one is correct. In the previous video, I believe we called these A, and I think this was J. A over J equals, I think I called this one C over K or something like that. Go back to the old video to see how that works. We now move on to number 22, and we're almost done. 22. If OS is 8 and ST is 12, and OV is 10, we're looking for OW. Now, of course, we were told that the two, no, we're not told they're similar. We know they're similar because these guys are parallel. If these guys are parallel, we do indeed have similar triangles, but then reverting back to the one of the most recent theorems, we also know that 8 over 12 has to equal 10 over VW. That's one way to do it. Let's go with that. 8 over 12 equals 10 over VW. Matching up our A over B equals C over D concept here. Hey, let's reduce 8/12ths. Be nice to ourselves. 8/12ths divided by 4 and divided by 4. That's 2 over 3 equals 10 over VW. All right, so 5th grade method, 4th grade method, whatever I call it. 2 times 5, 3 times 5. VW is 15. VW is 15. Are we done? No, we're not done, because they didn't ask for VW, so you've got to read carefully. They did not ask for VW. They asked for OW. Well, if VW is 15 and they told us this guy is 10, then the whole thing must be, how about 10 plus 15? Yes, it's 25, not 15. Yes, there are other ways to go about it, but we'll stick with that one. By the way, remember Theorem Pier 3 that you could have used here, but it wouldn't really make much difference. Theorem Pier 3 says, I am allowed to reduce the 2 with the 10. If your parents happen to be watching this, they might say, no, you can't do that. Well, yes, you can. The 2 and the 10 reduces to a 1 and a 5. Then if we cross multiply, or if we use the 4th grade method, let's just cross multiply this time. 1 times VW equals 3 times 5, 15. It does indeed work, and it always will. Then if that's 15 and that's 10, the whole thing is 25. All right, let's move on to number 23. Number 23. Okay, so what's up with 23? Is 23 the last one? Almost. Okay, number 23. If OS is 8, and ST is 12, and OW is 24, the whole thing is 24, then what's VW? All right, this one's a little bit trickier. Let's call VWX just to make life a little bit simpler. I think the best way to go about this is going to be to say, well, it's whole side here to this piece, 24 over x, the whole side to the piece. So here we do whole side to the corresponding piece. Well, the whole side here is 20, and the piece is 12. So let's reduce this fraction. Let's divide both these guys by 4. That gives us 5/3. I call that being nice to yourself. And, they had to give it, they're going to give us a fraction again here. Nothing else we can do to reduce anything, so we will cross multiply. 5x equals 3 times 24, that's going to be what, 72, right? So x is 72 divided by 5, which is 72 divided by 5, that's going to be, I'm just going to cheat real quick instead of doing the in-the-head math, we get 14.4. 14.4. And again, yes, there are other ways to go about it. We could have done it the hard way and called one of these x and the other one 24 minus x, but we don't want to do that. All right, that's 23. Let's move on to the last one, 24. And let me see what the question was here in the book. Okay, at k, is the bisector angle, okay, okay. So they've simply told us we have a triangle ABC, and they didn't even give us a diagram this time. How about that? We don't need a diagram, that's all right. A, B, C, placing this point names at random. Now, they told us we have the bisector of angle B. The bisector of angle B, meaning these angles are congruent. That theorem kicks in that we saw, the very last theorem of the chapter, we saw it before you guys left me, that A over B equals C over D. So, what's that give us? They tell us that. AB is 18. AB is 18. BC is 24. AC, oh, they're being mean to us. The whole thing is 28. Oh, that was cruel. And they want us to find AK. Oh, and this is point K. I assume that's, yes, they tell us that the bisector meets AC at K, so we call this point K. Now, from there, the only way to handle this one, if the whole thing, and I would not do this to you on the test, but if the whole thing is 28, now suppose I call this one X. If the whole thing is 28, and this piece of it is X, then what's the other piece? Is not the other piece going to be the whole thing, but without the X? How do you say the whole thing without the X? That's called 28 minus X. And there we have it. We're about ready to go. So we don't need that 28 anymore. Oops. So we can now write our proportion, which says what? Let's just go 18 over X. 18 over X equals 24 over 28 minus X. 24 over 28 minus X. And from there, this is one of those cases where we can use theorem pure 3 very nicely. 18 and 24, let's divide them both by 6. Dividing by 6, I get 3. Dividing by 6, I get 4. So I now can cross multiply. 4x, multiplying this, guys, has to be equal to 3 times this whole thing, 3 times 28 minus x. So now we just do a little bit of arithmetic here. We have 4x equals 3 times 28. That's going to be what? So 84, I think, minus 3x. And then we're going to add 3x to both sides. That gives me 7x equals 84. For you algebra haters, I added 3x here, and I added 3x here to get these x's out of there. So I have 7x equals 84. Divide by 7, I end up with x equals 12, right? Yes, x equals 12, and we are done. All right, folks. Hey, you might want to mention to me when you send me your answers. No, you already sent the answers. You might want to shoot me a quick email and tell me if you like this format of me being invisible. To be honest with you, I don't like it. I need to be able to point at things on the board and use my hands. Now, don't bother sending me an email about that. It'll just clog up my inbox. I don't like it. I don't think it works very well. I hope it doesn't cause you any problems. I've tried to be as clear as I can be. Um, but we will end it there. And is there anything else I need to mention? Remember, there's a guaranteed test question. I'll give you something like A over B equals C over D, probably with different variables, maybe even a number or two thrown in. And I'll ask you to write that 3 other ways. We've been through this before. Go back to the old video. You would do it upside down, which would be B over A equals D over C. There's one answer. Then read it sideways. By sideways, I mean A over C equals, going sideways like this, A over C equals B over D. So there's a second answer. Then we have what I call sideways backwards. Sideways backwards would look like what? C over A equals D over B. C over A equals D over B. Or you could even get tricky if you wanted to and add this denominator to this numerator, giving you A plus B over B, as long as you do the same thing on this side and add this denominator to this numerator, which would give you C plus D over D. If you want to be bold and try that, that is a legitimate correct answer. I will only ask you for 3. If one of your 3 is this, you are correct. Here's an example of a wrong answer. And every year, multiple people do this. They take one of these answers and they flip it around. They might take this one and they write B over D equals A over C. What's wrong with that? It's just the same thing as this one. That's nothing new. That is exactly the same proportion as the one above. So I can't count that as correct. That is not a new proportion. That's the same one you already did. These are the only correct new proportions that you could write. All right, don't forget what scale factor means. If you have a couple of similar triangles, such as these, and I tell you this side is 3 and this side is 4, now let's make it harder. This side is 6 and this side is 8, and I tell you they are similar, and I ask you for a scale factor. The scale factor is 6 to 8, better known as 3 to 4. Yes, I do expect you to reduce your fraction. Anything else that comes to mind regarding the test? Not really. I'm going to declare us to be officially done. And the test, again, will be emailed to parents tomorrow morning, and I'll expect to have it returned back to me by email by 3 o'clock tomorrow. All right, that's it. And now I've got to figure out how to stop this thing. I think if I hit the stop button,